And then in OChem, we just went over alpha beta stuff and the carbohydrates, so I have a little better understanding of that.
It's all which way that each group goes.
Well, I thought I understood it, and then we started talking about D and L and how it changes, and that threw me off a little bit there. So
what happens if we, maybe for just the sake of picturing it, see if we can.
here, I'm going to jump to this other side.
Yeah, go for
see
it.
a little bit better, since you're right-handed.
See if we can draw it in a way that makes it make sense. So, just like in OChem, a carbonyl is a really good electrophile.
Okay.
So what's going to happen is this oxygen, because the most stable ring has 6 members, so if we count here, knowing that this carbon is going to be one of them, 1, 2, 3, 4, 5, then the oxygen
6
is also going to be part of it. So, I guess the best way to think about this is, let's say this oxygen is gonna come around this way and attack here.
So it's the oxygen down on the bottom here. The
Yeah.
one number off the number 5 carbon there.
Yeah, because it will be the 6th member of the ring.
And that's going to act as an electrophile for the hydrogen up there.
This will be our nucleophile. This carbon here,
Oh, nucleophile, yeah.
this is our electrophile.
Right.
So this oxygen, maybe if I, because it took me a while to think this through in OChem, because you lose track of which oxygen is going where.
Yeah, that's kind of what I want to get down here.
So when that comes, then we get like this negative charge here. That hydrogen's off here. And so we think if this is wrapping up this way, this hydrogen that's here is probably going to be back. And now this, it's off of this carbon here, this CH2 is now up and out that way.
Right. Okay, so when this oxygen comes up and hits the hydrogen there,
Hits this carbon.
it hits the carbon.
Yeah, it attacks carbon.
Ha ha ha, that helps, that helps.
So like this is going to come, and then this double bond kicks up to
Okay.
here.
What happens to the hydrogen
Right here?
on the alcohol down here?
It's going to get deprotonated.
It does
I probably
deprotonate.
should, yeah, I need to show that, because there's going to be a positive charge, and then probably some base in here will steal that. It'll probably be one of the
Just like water.
first
or
things that
something,
happens.
Yeah.
And then this will pick up a hydrogen somewhere and become an OH. Yeah.
Okay.
And that
Okay.
is, and whether it goes up or whether it goes down is alpha versus beta.
So the oxygen, the carbonyl, that doesn't grab the hydrogen there. It's like a base deprotonates and then it gets protonated.
Yeah. Stoichiometrically, we'd say that this hydrogen moves there, but it's probably a different hydrogen.
It's a little different mechanism. Okay.
Probably something different. And then, so we're thinking here, that means this OH, if this wraps around and attaches here, this OH, let me make sure so we have glucose in the ring form. Okay. So it looks like we have to picture this, how this oxygen would be down.
Oh, I remember this because if the OH is on the right, it's D. So that side is down.
Okay.
I think. I'm pretty sure that's how it goes.
So then we know that this oxygen OH is down, this carbon, this OH is up. And then this one is also down, and then we're attached here. And then whether this OH is up or down, it gives us our alpha versus beta.
Right, right. And that's is that because, does that break and become a sigma bond there for a second so it can rotate? Or
This one here,
yeah.
it's just when it comes in, it just depends if it comes in on this side or comes on this
it's
side.
like an SN2.
Yeah, whatever way the oxygen gets pushed.
Oh, no. It comes in, it's probably trigonal planar when it hits.
So it can come on in
that
either
makes
face.
sense. Okay.
So, by being a molecule, it takes a lot of time to work it out. Like when you, okay, if this were to
Yeah.
rotate, how would everything go? It helps make these things make more sense because they'll naturally go down and up.
Yeah.
These won't change.
Yeah, I gotta think of that as a three-dimensional structure. I guess it'd probably be bending away from us
Yeah.
to cyclize, since those are coming out towards us, but.
And I guess for this to stay in the up position, as this comes, meaning we're gonna take this and flip it this way, this OH is now down, that OH would be up.
Yeah,
Refer to
yeah,
there.
it's like turning it here clockwise and then kind of angling it up a little bit is what we're
Yeah.
looking at here. Maybe.
And so, but really, you probably don't have to show why these come up as long as you have it memorized down, up, down for glucose or right, left, right, right.
Okay.
Because I don't think he'll probably make you do too much mechanism other than knowing this oxygen attacks here, that picks up a hydrogen, that hydrogen gets deprotonated.
Yeah, just being able to say this becomes this. You don't necessarily have to show how.
And so then this carbon on the carbonyl is the one that becomes our anomeric carbon there.
Right, okay. Okay. On the,
No,
for it.
no, you're
I don't
good.
mind.
I was just turning so it wouldn't buzz.
Oh, okay. I had a question. So when we're looking at, so this is a Pyranose
Mm-hmm.
ring, right? So with the Pyranose,
Yeah.
like in OChem we were looking at it a little bit with some of these that like you'd have the 4 carbon, is it 4 carbon, 5 carbon sugars?
Mm-hmm.
And sometimes they would become a Pyranose, sometimes they'd become a
Pyranose.
Pyranose. Do I need to worry about that? Do you
Like
think-
why it happens?
Or do I need to worry about
Whereas
like it happening here in the OChem class?
the only one, he probably just wants you to specify the furanose for fructose, but
Yeah.
fructose can do both, and that's a pretty common one. Whereas
If I remember, it went like 50% Pyranose for one of the forms or something. So that's what made me want to ask about it.
where is
I
that fruit? Yeah,
fructose.
right, cardinal left, right, right.